Good afternoon. My name is Karin Habshi, and I'm going to give you the ANST 300 course. And I hope that you will enjoy this course. First of all, I would like to know more about you. What is your background? Because sometimes we have students from different backgrounds other than engineering. And this is why this course is made in a way to be accessible to all types of majors. If you have a economical major or engineering major, you will be able to go over this course. I will try to go over the engineering concepts because you know that if you are not an engineer, you don't know them. This is why for each chapter, we'll have like an introduction for the basics that maybe engineers know them, but also you can remember them in this way. You will see that we'll have some review on if you want fluid mechanics, thermodynamics. So we'll need several fields in this course, because this course will deal mainly with energy and how we transform energy from one form to the other. So we'll go sometimes over some chemical engineering, some electrical engineering, some mechanical engineering. So if you want, it's a mixture of several information, and what is common between them is how we go from one form of energy to the other. Plus, of course, we'll add a certain economical part at the end, because whenever we want to design a system or we want to opt for a new engineering strategy, we need to study it on the economical level to know if it can be implemented or not. So this is an overall a small picture of the course. So as I told you, as the first step, I want to know more about you. I will start with Adam. So please introduce yourself, your background, and why you selected this course. I will start with Adam.
Yes, good evening, Professor. First of all, I'm a senior mechanical engineering student, taking this as a technical elective inside my major. Taking it mainly لأنه we have the background of heat transfer, thermodynamics, and all those. So كمان لأنه it's an interesting and essential course to take in this day and age يعني. That's the reason why I'm taking it.
Okay, Adam, thank you. Andrew?
Yes, hello.
Hello.
Hi, my name is Andrew Musa. I'm also a senior mechanical engineering student. Also taking this course as a technical inside. The main reason why I'm taking it is because I'm also trying to focus more on the energy side of the field, and the energy studies course seems to be the feasible one to take.
Okay, thank you, Andrew. Majd?
Hello, Professor.
Hello.
So my name is Majd Faris, and I'm also a senior mechanical engineering student at AUB. And I'm also taking the course because I'm more interested in the energy track offered by mechanical engineering. And I hope it'll be fun. Thank you.
Thank you, Majd. Eli Abi Asad?
Yes, hello, Professor. So,
Hello, Eli.
like the other guys, I'm also a senior mechanical engineering student. And I chose this course because I'm trying all of the different tracks, to be honest. And I wanted to start with an introduction to the energy sector. So that's why.
Okay, great. George Fram?
Yes, hello, Professor.
Hello.
I'm George. I am a senior mechanical engineering student. I'm taking this course as a technical elective because I'm interested in the environment and any green solutions that we can come up with as engineers. And of course, sustainable energy is a very big part of that. So I would like to get to know more about energy in general.
Great. Look, we'll talk now. One of the major part of this course is the project. So we'll discuss some ideas. And of course, if you are interested in any idea related to the energy field, you can propose it, because next time we'll start with the ideas for the projects, and we'll select for each group a certain project to start with. Thank you. Jimmy?
Hello, my name is Jimmy Saliba. I'm also a senior mechanical engineering student. And the main, actually, two reasons why I chose this course is one, because I took MEC 674 or ENST 305, and I enjoyed it. So I thought I could take a similar course to it. And two, because I also heard that this course offers a lot of new knowledge, especially for us as engineers, and it can help gain more general knowledge. So I find it interesting.
Great, Jimmy. You know that I will teach 305 now, and you have, these two courses are very related. You will now benefit maybe to go deep more into renewable energy, because in 305, okay, we talk about renewable energy, we talk about different forms of energy, but we don't go deep into the engineering details, because we focus more on the
Yes,
economical
exactly.
part. Yeah, so here you can take advantage of knowing more about these energies. Thank you. Joe Dahrouj.
Yes, hello, doctor.
Hello.
My name is Joe. I'm a senior mechanical engineering student, and I'm taking this course because I want to apply for master's in energy engineering. So I guess
Great.
it's it's
Okay,
better to
Joe,
delve into energy
and
studies.
which part in the energy is, you know which part you want to work with, or just not yet?
I'm guessing oil and gas production. Oil and gas
Great,
production.
great. Okay.
Yes, thank you.
Leia?
There's two Leah, I think.
Okay, Leia
Yes, doctor,
Yunus.
there's two.
Okay, Leia Yunus.
Yes, hi, doctor.
Hello.
So I'm majoring in energy studies at AUB. This is my second semester as a graduate student.
Oh, wow.
And this course is a core course.
Okay.
In my
And
major.
your first master was
and
in
I'm
what?
looking forward.
Your first master was in which field?
No, this is my first master's degree.
I saw
was an
this is the second
undergrad.
one. Okay, great. Okay.
No.
Okay. Thank you, Leia. Leia Labaki?
Hello, my name is Leah. I'm an E4 student in mechanical engineering. I took this course because my friends took it last semester, and I saw the concepts they were learning, and like this course includes the nice parts of thermodynamic and heat transfer. And I also took 674, and as Jimmy said, it's a nice continuation of the course if I want to see the non-economical view of energy.
Yes, great. Okay, thank you. Mirna?
Yes, hello, doctor.
Hello.
My name is Mirna Bakri. I'm a first year energy studies student. This is my second semester at AUB. I took this course because it's a core course, of course, and it's interesting to know more and go deep into thermodynamics and heat transfer.
Okay, thank you, Mirna. I hope you will enjoy it. Thank you.
Me too.
Muhammad?
Hello, I'm also as well a senior mechanical engineer. I took this course because I have an interest in renewable and sustainable energy. And I also took MEC 674, which also gives a lot of the policies that are taken into to like expand on sustainable and renewable energy nowadays. So
okay, yes, thank you, Muhammad. Nadim?
Hello, my name is Nadim Abdul and I'm a senior mechanical engineer. So I took the course because it was highly recommended by my friends who took it in fall, and it's like a very important course to understand the way that and the track that the energy is going in.
Thank you, Nadim. Okay, Sarah?
Hi, Professor. I'm also a mechanical engineering student. I'm taking this course as a technical elective, and I chose to take it because I wasn't sure what track to go into, and I never took an energy course before, like a core energy course. So I decided to take it, see if I would like to continue in this track. And a lot of my friends took it last semester and they recommended it, so I thought I'd take it too.
Okay, thank you, Sarah. Seth?
Hello.
Hello.
I'm Chris Kabjali, and I'm taking because I'm also
Seth, we cannot hear you very well.
is this better?
Yeah, it's better.
Okay. I'm saying I'm a senior student because I'm
Seth, we have a problem again. Look, if you want, try to change your place and we'll go back to you.
okay.
Okay. Okay, guys. So now I will just introduce for you in brief how the course is decomposed. So on Moodle you have several sections. Okay. To start with, you have the course syllabus, where you can find the division of the course and how we'll go over it now together, how the grade is divided. Now, to start with, you have here the announcement. In the announcement part, you have several articles that will describe for you, if you want, several ideas related to energy. This will help you to select an idea for the topic of your project. You are not forced to take one of these ideas. You can select what you want, but these are some possibilities. So for example, you have, let's say, an article on renewable energy. Of course, when we talk about renewable energy, it's a very large field. We can talk about solar energy, wind energy, hydropower, etc. So you can select any of these types and go deep into it when you do your project. You have, for example, here also information about financial risk analysis of renewable energy technologies. If some of you like to go more deep into economy, you can go through this and you can compare different renewable energy techniques through financial risk analysis. Another option is the climate change. We'll see in this course that because of production of energy, we have global warming issues, we have CO2 emissions, and this caused a considerable climate change in the planet. And therefore, if we continue to do it in the same way, we can reach very high temperatures, and we have a risk on the life on the earth. That's why we should pay attention to climate change, and we should go through strategies to avoid, if you want, bad effects of climatic change. Another possible topic is about harnessing the energy of small bending motions. For example, you can see how we can convert footsteps in energy into electrical energy. This is a very nice innovation. And we can, it can be from footsteps, it can be from bending motion. So these two are related, these two ideas. You can benefit from this small amount of energies to accumulate them and store them, to use them for other purposes. Another possible topic also is rising ocean temperature. I have, one of you said that you are interested, for example, in the effect on environment. So we always, in energy, we try always to reduce bad effect on the environment when we study energy strategies. So we know that we can have energy in the easiest way by burning fuels. This is the easiest thing we can do, but it's very harmful to the environment. That's why engineers started to think about new strategies, new ideas that will reduce the harmful effect on the environment, and at the same time go to strategies or use energy that is renewable, not like fossil fuels. You know that we need a lot of time to have fossil fuel. And also we have reduction of reserves. With time, the reserves of fossil fuel are getting used, and at a certain level will not have any more these reserves. We'll go, for example, to other types of fuels. We will go to biofuels. So, and for each type you have limitations. Even biofuels, you have a complete science that is studying how we can have safe biofuel to the planet. So each of these topics can take you to a lot of ideas on how to use and how we convert energy from one form to the other. Other possibilities, for example, is also to study oil companies that are investing in windmills. So as we suggested, as we were talking, oil and fossil fuels are currently the most used source for energy, but we are trying to use them with other strategies, like, for example, wind energy or solar energy, because sometimes renewable alone is not enough, but at least it can help us, it can be used in auxiliary with other forms in order to reduce bad effects of the conventional technologies or the conventional methods that produce energy. Another very important idea also that is currently under research is Hyperloop transportation, which is using renewable energy strategies for transport. So this is also a nice topic. You can read here about hydrogen generation with limited carbon emissions. So as we mentioned, carbon emissions are very harmful, and that's why we are coming up with new techniques, or we are coming up with new types of fuels in order to reduce the bad emissions. Okay. Plus, also we'll see that we have some strategies to store CO2 in a certain way that is not harmful and use it for positive effects. We'll see how. In addition, you can also talk about nuclear energy generation. So one of the forms of energy, which is a very powerful energy, is nuclear energy. But we know that this type is very risky, and we should have a lot of safety measures when we deal with nuclear energy. Other possible ideas for projects are, for example, harvesting energy from the sun, wind, and temperature using 3D printed trees. So this is another invention that is used to benefit from the solar energy. You also have supercapacitors that are used for energy storage. You know that energy is very important, and sometimes we have it in excess. So when we have it in excess and other days we don't have it, we need to store it. So the energy storage is a field in its own, because we need to come up with, let's say, batteries with supercapacitors that are high efficient and can store energy for a long period of time to back up our systems. Another possibility also is nano flow cell for transportation. You know that the nano field is, with the adventure of technology, everything on the nano scale is becoming more and more important. And we are doing a lot of research and development on these subjects. And we'll see how we can use it also in the energy field. As we mentioned, the storage is important a lot in the energy systems. That's why you can study flow battery that could store wind, solar, and other types of energy. Other possible topics are compressed air energy storage, solar roadways, modular reactor, etc. So all of these articles or sites, okay, are given for you to give you ideas about energy. And if you don't know until now what is your interest, you can have some reading and select the topics that you want. So this is one of the possible topics. So if you want, during this week, you can just have some reading. So next week, when we talk about the projects, you will be ready to select an idea and start with the work on the project. Now, of course, here for the first section, you have the course syllabus, where you can find the content of the chapter. You can have some references. you have a lot of books as references in this course because we have a lot of disciplines here. But what you have in the slides is more than enough. I will give you everything you need in the material. But in case you want to refer back or you want to practice with problems, you have also books. So we'll go over the syllabus together, and we'll talk about the textbooks.
Doctor, sorry
Yes.
for interrupting.
Yes, tell me.
But this course isn't found on Moodle.
It's not
on my Moodle.
okay.
at
Look, I
least.
will check. Is it the same for all? You cannot access it yet?
Not yet.
Okay, look, I will see what is the issue. Okay, I will try to see if there is something from my part. If not, I will contact the IT to fix the issue. Okay.
Okay, thanks, Doctor.
Welcome. Okay. So this course covers, as we discussed, the course covers the fundamental principles underlying the generation, storage, and delivery of energy. So as we discussed, you have, whenever we talk about energy, we'll see first, in the first step, how we generate energy, or how we, if you want, you know that energy cannot be created. The generation means, if you want, how we can go from one form to the other, and how we can convert, let's say, from electrical to chemical, or from chemical to electrical, from mechanical, let's say, to electrical, or vice versa. It depends on your application, from solar energy to electrical energy. So this is the process. When we talk about generation, we are talking about this process of how to go from one energy form to the other. Concerning the storage, as we discussed, sometimes we have excess of energy, so we need to store it. And a very simple example of this is, let's say, a small house, and we want to ensure the electrical need using solar energy. For example, currently in Lebanon, one of the major problems is electricity, because we were used to have electricity all time, and now suddenly we have problems. We don't have, even with generators, we cannot have it 24/24. That's why the Lebanese people were motivated to go to other strategies like solar energy. Okay, so the idea is simple. Let's say we have, all we have to do is to put a small system. Let's say we have the solar panels as the first stage. So we'll have a chapter to describe how solar systems operate. So as a first step, you need to absorb first solar radiation. So of course you should study the design of your PV panels in a way to have high efficiency of absorbance. And of course you have to have, let's say, some heat exchanger here. Let's say you have tubes, and water goes through these tubes, and the energy that is trapped from solar radiation will be transferred to water circulating in the tubes. So here we are transferring, if you want, the solar energy to an energy that is heating a refrigerant. And after this, after heating water, we can use this water, for example, let's say we can use it for domestic purposes, okay? Or also we can use it in a heating system. Plus, if we want to produce electricity, okay, we can use the conventional, let's say, a cycle that is transforming heat to work. Or also we can go to other techniques that will, let's say, the concentrated solar system, for example, that can directly trap the intensity and transfer it in a certain way to electrical energy. So we'll go over the techniques in detail together when we go through the solar renewable energy. Okay, so this is the stage we'll study. In this stage of generation, we can study all the science beyond and all the physics beyond the transformation of energy from one form to the other. Now, This system, and if we take the example of the easiest application of solar energy, which is heating water, if we just want to use the heated water for domestic use, okay, let's say for shower application, for example, then we need to store this water in a certain medium, okay? And of course, the storage medium should be well insulated to not have dissipation. Plus, in case we are not using now, and if we don't need to use now the water, okay, we need to have large reservoir, or we need to have like PCM materials, let's say, in order to store this energy that is in excess now and we don't need it, so that after, during the night, if someone needs to do a shower, we can have water for a long period of time. Because, for example, phase change material are compact and at the same time are characterized by high energy capacity. So they can be used in this application to use hot water for a longer period of time. And of course, concerning the delivery of energy, it is just the way to give it at the end use. Okay, sorry, we had some connection issues. Do you hear me now?
Yes, doctor.
Yes.
Okay, it's fine. Yeah, I will share again. Okay, so we were talking about the different phases of generation, storage, and delivery of energy by giving a small example, which is domestic hot water. Now, this course will introduce you to variable techniques of energy production, including fossil fuels and renewable energies, such as wind power, solar energy, hydropower also, etc. The course will discuss energy storage techniques and will address the environmental and economical impact of energy generation and delivery. So as we already mentioned, it's not enough to produce energy. We should know its effect on the environment, plus we should know the economical impact of the project. You might have a very strong idea, very original idea in the engineering field, but if you want to implement it, or if investors want to implement it in a country, they should make sure that it's economically viable and that you will have a certain benefit on the economical level from it. So already, of course, if you have taken energy economics, or if you have taken NST 305, of course, you have an idea how to do economical analysis. We will apply this some parts of the economical analysis on problems related to the energy production, generation, and storage. Now, in addition, we'll cover subject for students with backgrounds in science and engineering that, as I told you before, the majority of you are of engineering background, but even if you are not, if you are of economical background or any different background, this course is made in a way to facilitate things for you the maximum. So I tried as much as possible to repeat all concepts that are supposed to be known from previous courses, as heat transfer or fluid mechanics, and make it relatively simple. Okay, so that's why I hope that mechanical engineers will not be bored a lot, because each time I will repeat all concepts before applying them on what we are learning. And we'll apply this knowledge on different, if you want, fields related to energy, like photovoltaic cells, wind powers, batteries, and nuclear power. Plus, we'll go through fundamentals of fluid thermal physics and the mechanics in order to understand the different ways to transform energy from one form to the other. Now, the prerequisites courses are basic physics, introductory to thermal and fluid science, basic calculus, and basic computer programming. You can use computer programming in your project. I will not force you to do it, but it will be good. Using some programs can help you into having good results in your project. So we'll see that for the project, I will give you if you want a lot of possibilities, and you can, depending on what you are interested in, you can focus on the economical aspect, you can go more deep into engineering, but it will be nice to put something from different fields, because this will help you to have your project multidisciplinary. And you can use, let's say, some simple softwares. For example, let's say if you are modeling, let's say, a building, you can use Energy Plus. You can use, which is, if you want a more advanced, if you want softwares than HAP, you know how to use HAP and the basic calculations, you can go to Energy Plus, because it can help you to illustrate your system. You can study, you have more options than HAP, etc. So you can use some softwares if you want in your project, if you know them, or if you are interested in a certain softwares that can help you or add to the contribution of your project, you can do it. You can use ANSYS Fluent, and if you need any help, my whole thesis was on CFD modeling and energy modeling, so I can help you if you want to go through, let's say, computational fluid dynamics and do some simulations on CFD. You can use simple programming tools as MATLAB, for example, if you want to conduct your economical study. And of course, you will not do all calculations on your own. You can just program this. So you can do any of these as a contribution in your project. Now, concerning the textbooks for the course, as I mentioned before, because it's a multidisciplinary course, you will have textbook from different fields. But as I told you, all material you need to know about is in the slides. But in case you need to go more deep, you can have some readings in these references. So for example, you have the book of John Andrews and Nick Jelly on energy science, on principles, technologies, and impacts. You have fundamentals of renewable energy processes for Aldo, solar engineering of thermal processes, renewable energy resources, etc. And of course, for the fundamentals, you have the books of mechanical engineering, let's say thermodynamics, fluid mechanics. But as I told you, everything is repeated for you on, in the slides. Now, concerning the course objectives, so I hope that in this course you will be provided with fundamental scientific principles governing the generation of energy and its use in society. We'll introduce you to the different ways of generating, storing, and delivering energy. And we'll develop appreciation of the environmental and economic issues that need to be addressed when using energy in our life. Now, the different chapters we'll go over. We'll start first with an introduction to energy science. So you have a little bit of history in this chapter. Please don't worry, you will not have to remember any of the dates or you will not have to remember history information. Just you need to understand the content, and you will see that, for example, in the exam, I will tell you the style of questions. Let's say in the exam, you will have some multiple choice questions. So just you need to have general knowledge. You are not responsible of dates, of very tiny details. Just you should read the slides and understand them. The second chapter will be if you want, a review of thermodynamics, because we'll introduce thermal energy. Since we'll use it a lot in the chapters coming after, we'll revise together cycles of energy, how to produce and how to transform energy from one form to another in cycles. We'll go over the ideal cycles first, like Carnot cycle. Then we'll go over Rankine cycle and the different modifications that can be done on it to enhance its efficiency. After this, we'll go over energy from fossil fuels. We'll see how fossil fuels are formed with time and how we can get energy with them. What are the disadvantages of using fossil fuels, etc. After this, we'll go over the main fluid mechanics for energy conversion, because this will help us into understanding after hydropower. because you know that, let's say you are familiar with the Bernoulli equation. The Bernoulli equation, which is a very simple tool, is the fundamental equation of hydropower, for example. After this, we'll go over wind power. Also, we'll study physics of wind power, some equations related to it, and what are the different systems that can be used for to use energy from wind. After this, we'll go to solar energy and the different application of solar energy. Solar energy is one of the biggest fields in renewable energy. You have a lot of systems relying on solar energy. Now, for example, we are hearing about, let's say, cars that are moving under the effect of solar energy. So solar energy is getting more and more important in our life. And as we mentioned, we can go deep into different fields related to it. And in the final chapter, we'll develop methods to study the economical effect of any project we propose. So of course, in your project, for example, you will select a certain idea and you will study it. And at the end of your project, it will be very interesting to add a certain economical part to propose your method or your idea and say why this idea will be better than other ones. So this is mainly the content that we'll go over. The course outcomes. So at the end of this course, hopefully you will have a clear understanding of the different means of energy production and environmental impact. We'll try to design a system for energy generation and analyze its benefits, limitation, and economic implications. So mainly in the project, you will be able to go over the steps of design, how to design an engineering system, for which application, how we study it, how we compare it, let's say, to previous systems, how we try to enhance its performance, etc. So this is in brief what we'll do in this course. Okay, any question?
Professor, I have a question about the grade distribution.
Yes, sure. Look, I will open a new meeting because we have less than 1 minute and we discuss the grade distribution, okay? So please join again using the same link.